In the winter of 1893, in the renovated district offices of Lower Manhattan, a city building inspector named Thomas Warren stood on a suspended scaffold 3 stories above cobblestone, examining what should not have been there. The structure, recently converted from a textile warehouse, bore all the expected modifications: reinforced floors, new interior walls, gaslighting brackets mounted in orderly rows. But on the building's southern facade, preserved beneath layers of whitewash, was a door. Not a window bricked over or a delivery hatch sealed with boards, but a complete door frame with hinges still attached. Sim 600s, opening 15 feet above the alley below onto nothing but winter air. The morning light caught the threshold, revealing wear patterns, deep grooves in the wood where something heavy had been dragged across repeatedly. Warren's inspection notes, preserved in the municipal archives, record the measurements. Standard residential dimensions, 32 inches wide, 7 feet tall. In the margin, in different ink, someone had written, "Query ventilation, check ledger 1847. The ledger, when located 6 weeks later, offered no clarity. The building, originally constructed in 1834 as the Mercantile Warehouse No. 7, showed a floor plan that matched current dimensions. But a separate sheet, loose between pages and dated April 1847, listed elevated portals, 6 units, purpose coal transfer. The handwriting was formal, bureaucratic. Below it, in pencil, partially erased, "Pneumatic, test suspended." No explanation followed. The photographs taken during Warren's inspection, held now in the city's historical collection, show the door clearly. In one image, taken from the scaffold itself, the camera looks directly through the open frame. The opposite building, a printer's shop, is visible across the alley. Between the two structures, nothing, just air. And far below, the shapes of carts and pedestrians rendered small by height and perspective. This was not an isolated case. By the time Warren submitted his report in March 1893, similar features had been documented in 17 buildings across Lower Manhattan, 12 in Brooklyn Heights, and scattered examples in Philadelphia, Boston, and Baltimore, all dated from the same narrow window, 1834 to 1851, all at similar heights, all with the same worn thresholds, the same standard dimensions, the same absence of external support structures or remnant hardware that might explain their original function. The city's official position, recorded in a memo dated April 14, 1893, was brief: architectural vestige, loading apparatus removed, no current hazard if sealed. The memo was typed on official letterhead. At the bottom, handwritten in the same pencil as the warehouse ledger, "Pneumatic coal, ask Whitmore, re-patents." Charles Whitmore, according to census records, was a patent clerk in the United States Patent Office from 1839 to 1862. His resignation, dated January 1863, cited exhaustion of duties. A search of patent applications filed between 1834 and 1851 under keywords pneumatic, coal, transfer, and elevated yields 37 results. 34 describe conventional systems: steam-powered elevators, rope and pulley arrangements, inclined conveyors. 3 applications. Time, 450 Ms, filed in 1846, 1847, and 1848 respectively, are marked withdrawn prior to approval. The files themselves are noted as transferred to private archive, Interior Department request, June 1851. No copies remain in the public record. A notation in the Patent Office's internal register, discovered during a 2003 digitization project, lists the withdrawn applications by number: 4,447, 4,521, and 4,603. Next to each, matter of efficiency, national, interest. The term national interest appears again in a letter dated July 12, 1851, from the Department of the Interior to the Mayor of New York City. The letter, brief and procedural, requests the cessation of installations related to experimental coal transfer systems utilizing pneumatic pressure within municipal boundaries. It cites concerns regarding structural integrity and public safety. The tone is administrative, almost perfunctory. Yet a separate communication, sent the same day to the city's building commission, is more specific. All elevated portal installations are to be sealed or removed. Existing apparatus is to be dismantled. Records of installation locations and operational parameters are to be forwarded to this office by August 15th, 1851. Both letters are signed by the same official, though the signature is illegible, a flowing script that contemporary handwriting analysis suggests may be deliberately obscured. By autumn of 1851, the doors, if that is what they were, had begun to disappear from official documentation. Building records updated that year and the following show the structures described instead as level moderate ventilation apertures or former loading bays. Several were bricked over entirely. Others, like the one Warren documented in 1893, were left in place but sealed, their function erased from memory, if not from the physical fabric of the buildings themselves. Photographs from the period are rare. Architectural documentation of commercial structures was not yet standard practice. But in a private collection held by the New York Historical Society, a daguerreotype dated circa 1849 shows a warehouse in what is now the Tribeca neighborhood. On its third floor, clearly visible despite the image's silvery blur, Times 600 Misperdummerstad is an open doorway. Standing in the threshold is a figure in worker's clothing, one hand on the frame, looking down. The pose suggests routine, not danger. Behind the figure, dimly visible, is what appears to be a metal cylinder, perhaps 3 feet in diameter, oriented horizontally. The cylinder reappears in other fragmentary records. An insurance adjuster's report from February 1850, filed after a minor fire in a Baltimore warehouse, mentions damage to pneumatic apparatus on third floor, iron cylinder and associated valving, total loss estimated at $340. The report includes a sketch, a horizontal cylinder, perhaps 8 feet long, connected to a series of pipes. One pipe extends to an exterior wall. The adjuster's notes describe unusual configuration, no similar installation observed in comparable properties. The warehouse was demolished in 1889. No trace of the apparatus survives except in the report's ink and paper diagram. The lines confident, the proportions precise. On November 3, 1902, a mechanical engineer named Harold Voss, writing in the Journal of the American Society of Mechanical Engineers, published a brief article titled Pneumatic Systems in 19th Century American Industry. The piece is largely technical, describing early attempts to use compressed air for material transport, but in a footnote, Voss mentions a rumored installation in New York and other eastern cities circa 1845 to 1850, utilizing high-pressure air to propel coal or other materials through tubes over considerable distances. He cites no sources, offers no details. The footnote ends, no contemporary accounts of successful implementation have been located, though anecdotal evidence persists among engineers of the period. Voss himself died in 1917. His personal papers, Time 100 Oz, donated to Columbia University, include notes for a never-completed follow-up article. Among them, a single sentence. Whitmore's system, military application. Military interest in pneumatic technology was well documented by the mid-19th century. Compressed air had been proposed for powering torpedoes, launching projectiles, and operating mine ventilation systems. But material transport, moving coal specifically, through elevated pneumatic tubes would have required pressures and engineering tolerances far beyond what contemporary technology openly achieved. The physics are straightforward. Moving a solid mass through a tube using air pressure demands a tight seal, minimal friction, and sustained pressure differential. Contemporary systems, like the pneumatic postal tubes installed in some cities by the 1890s, moved lightweight capsules through small-diameter pipes over short distances. Moving coal, dense, irregular, abrasive, would require something different entirely. In a patent application filed in Berlin in 1854, a German engineer named Friedrich Kessler describes a pneumatic coal transport system for mine operations. The application, written in formal technical German, Time films details a system of iron tubes, compression chambers, and valve doorways positioned at mine shaft openings. Kessler's drawings show cylindrical chambers with loading doors at one end, discharge doors at the other. The scale is industrial, tubes 4 feet in diameter, chambers 10 feet long. Coal is loaded, the door sealed, compressed air introduced. The coal is propelled through the tube to a receiving station, where pressure equalizes and the discharge door opens. The application notes, particular attention must be paid to sealing mechanisms, as leakage renders the system inoperative. Kessler's patent was approved in 1856. Records indicate a prototype was built near Essen. No evidence of widespread adoption exists. A marginal note in the Patent Office file, dated 1858, reads, "System effective, but cost prohibitive. Manual transport remains more efficient." The doors in Manhattan and elsewhere, if they were connected to such a system, would have served as the discharge points, the openings where material arrived after being propelled through tubes by compressed air. Their elevation, 15 feet above street level, would place them at roughly the height of a building's third or fourth floor, consistent with the floor-level positioning needed to maintain a horizontal tube run. The absence of external support structures makes sense if the receiving mechanism was internal, a chamber or hopper built into the floor, with the elevated door serving as the discharge point into the building itself. The wear on the threshold suggests repeated use. The standard dimensions would allow human access for maintenance or adjustment. Yet if such a system existed, it left almost no trace. The withdrawn patent applications are gone. The Interior Department's correspondence mentions it only obliquely. The buildings themselves were modified, the doors sealed or removed, the apparatus dismantled. What remains are the doors, preserved by accident or architectural conservatism, opening onto air, their purpose forgotten or deliberately obscured. Warren's report from 1893 catalogs them as curiosities. Later documentation treats them as errors, architectural mistakes corrected in subsequent renovations. By the mid-20th century, they are barely noted at all. In the spring of 1967, a structural engineer named Elizabeth Harmon, surveying buildings slated for demolition in Brooklyn's waterfront district, photographed one of the doors. The building, a former warehouse scheduled for clearance to make way for highway construction, had stood since 1838. Harmon's photographs, preserved in the city's redevelopment archives, show the structure's interior: massive timber beams, brick walls 3 feet thick, and on the third floor, a sealed doorway facing south. The door itself had been removed, but the frame remained, bricked in sometime in the 1890s. On the floor beneath the sealed opening, Harmon noted remnants of iron fixtures, bolts extending from a floor. Pattern suggests heavy machinery once installed. Her diagrams show the bolt pattern, a rectangle approximately 6 by 10 feet, centered below the doorway. The spacing and diameter of the bolts suggest equipment weighing several thousand pounds. The building was demolished in June 1967. The fixtures, if they were salvaged, were not cataloged. A parallel emerges in England. Between 1836 and 1855, several industrial buildings in Manchester and Liverpool were constructed with similar elevated doorways. British architectural historians have described them as unfinished loading bays or ventilation features. But a survey conducted in 1978 by the Manchester Industrial Archaeology Society noted that the doorways, 9 in total, spread across 5 buildings, shared characteristics with their American counterparts: standard dimensions, similar heights, evidence of wear, and in one case remnant bolts in the floor beneath. A warehouse in Salford, photographed before demolition in 1981, showed the interior of one such doorway. The threshold was oak, worn smooth in the center. On the interior wall, barely visible in the photograph, was stenciled text: "Discharge point 3, pressure 40 psi, lever to release." 40 pounds per square inch is significant. For context, steam locomotives of the period operated at boiler pressures of 50 to 150 psi. A pneumatic system operating at 40 ps1 could generate substantial force. Calculations suggest that at such pressure, a well-sealed tube 4 feet in diameter could propel several hundred pounds of material at speeds approaching 20 miles per hour over short distances. The energy requirements would be considerable: large compressors driven by steam engines or water wheels. But for urban applications, where coal needed to be moved from ground-level storage to upper floors for heating and industrial use, such a system could eliminate the labor and time costs of manual hauling or block-and-tackle systems. The question is why it disappeared. Cost is the standard. Explanation: complex systems that offer marginal advantages over simpler alternatives often fail economically. But the abruptness of the cessation, the withdrawal of patents, the Interior Department's intervention, suggests something more deliberate, a technology suppressed perhaps, or a failed experiment hushed to avoid embarrassment, or possibly a system that worked too well with applications, military, logistical, that prompted official interest and subsequent classification. On September 22, 2019, a commuter waiting for a train at the elevated subway platform in Queens notices a building across the street, 4 stories tall, early 20th century construction. On the 3rd floor, a doorway, painted over but clearly outlined, opens onto nothing. No balcony, no fire escape, no visible explanation. The commuter photographs it, posts the image online. Within hours, responses accumulate. "I've seen those. There's one near my office. I always wondered what those were for." The thread grows, annotated with locations. Brooklyn, Philadelphia, Chicago, even Halifax, all old buildings, all similar heights. No one offers a definitive answer. The theories proliferate. Coal chutes, fire escapes, loading bays, architectural mistakes, remnants of demolished structures. The discussion fades after a few days, replaced by newer curiosities. Yet the doors remain, preserved in brickwork and renovation, anonymous and inexplicable. In New York, at least 30 are still visible from street level, scattered across Lower Manhattan, Brooklyn Heights, and scattered waterfront districts. In Philadelphia, 12. In Boston, 8. They appear in buildings constructed between 1834 and 1851, and then they stop. Buildings from 1852 onward do not have them. Whatever they were for, ended within that narrow window of time. The official records are silent or deliberately vague. The patents are withdrawn. The correspondence hints and deflects. The doors, sealed and painted, offer no answers. In a digitized archive maintained by the Library of Congress, a letter dated October 1850, from an engineer named Samuel Harding to an unnamed colleague, discusses progress on the urban coal project. Harding writes, "The latest trials demonstrate effective material transfer at distances exceeding 600 feet with acceptable loss rates. The elevated discharge points function as designed, though urban installation presents regulatory complications. It is my hope that these can be resolved by spring." The letter is part of a collection donated in 1962, its provenance unclear. Harding's name appears in no other documents related to pneumatic systems or coal transport. His death, recorded in Philadelphia in 1854, lists his occupation as civil engineer. No further details survive. If Harding's system was operational, it would have represented a significant technological achievement. Pneumatic transport of bulk materials in an urban setting, predating similar systems by decades. Yet it left no legacy, no commercial adoption, no mention in contemporary engineering literature beyond Voss's cryptic footnote. The buildings themselves, with their elevated doors, are the only physical evidence. They speak to intention, to installation, to use, but they do not explain why the system vanished, why the patents were withdrawn, why the doors were sealed and forgotten. The modern equivalent exists, though few recognize the lineage. Pneumatic waste collection systems, installed in some urban developments and hospital complexes, use underground tubes to transport trash from collection points to central facilities. The principle is identical: sealed containers propelled by air pressure through tubes. The technology is proven, efficient, unremarkable. In Dubai, a residential complex uses such a system, the tubes running beneath streets, the collection points marked by unobtrusive hatches. In New York, Roosevelt Island's pneumatic waste system, operational since 1975, transports garbage at speeds up to 60 miles per hour through a network of underground tubes to a central processing plant. The system's design, tubes, compression, discharge points, echoes the configuration suggested by the 19th century doors and their associated apparatus. Yet no one mentions the precedent. The modern systems are presented as innovations, products of contemporary engineering. The doors, when noticed at all, are curiosities, mistakes, remnants of vanished practices. The connection is not made. History has separated them, erased the line that might link a sealed doorway in a Brooklyn warehouse to a pneumatic tube in a Dubai apartment complex. If the 19th century system was real, if it worked, its memory has been edited out, replaced by a narrative of gradual progress and recent invention. In a basement archive in Philadelphia, a city engineer sorting through century-old documents in 2011 found a rolled blueprint, unlabeled, dated 1848. The blueprint shows a cross-section of a 4-story building, the floor plan standard for the period. But running from the basement to the 3rd floor is a vertical shaft, perhaps 5 feet square. From this shaft, a horizontal tube extends to the building's exterior wall, terminating at a doorway marked discharge point. The tube is drawn to scale, 4 feet in diameter, iron construction. At the basement level, time 450 millions. The shaft connects to a chamber labeled compression valve control. The blueprint is unsigned, its purpose unclear. The building, if it was constructed, has not been identified. The engineer photographed the document, uploaded it to the city's digital archive, noted it as pneumatic system design, unknown origin. The file receives occasional views but no commentary. The evidence accumulates in fragments. Warren's inspection notes, the withdrawn patents, Kessler's German application, Harmon's photographs, the Salford stencil, Harding's letter, the Philadelphia blueprint. None definitive, none complete. Together they suggest a system that existed at the margins of official history, tested, installed, briefly operational, then suppressed or abandoned. The reasons remain obscure. Perhaps the technology was ahead of the available materials, requiring tolerances that iron and timber could not reliably maintain. Perhaps it was too expensive, too complex, too dangerous. Or perhaps it worked well enough to attract official attention, to be classified, repurposed, erased. What remains are the doors, unextraordinary and inexplicable, opening 15 feet above alleys and streets onto nothing but air and forgotten purpose. They are visible in photographs, in renovation surveys, in the casual glances of commuters and pedestrians who pause, look up, wonder briefly, and move on. The buildings that house them are being demolished, slowly, replaced by glass and steel that bear no such anomalies. In another generation, the doors will be gone, their mystery dissolved not through revelation, but through removal. History is written by survivors, but architecture is read by those who know how to see. And the doors, silent and sealed, wait for someone to ask the right question, to find the missing patent file, to decode the marginal notes and recognize what was lost when the system, whatever it was, ceased to exist. The threshold is still there, if you know where to look. 15 feet up, worn smooth by something heavy, dragged repeatedly. Standard dimensions, no explanation, just air, and the echo of a question that official records have declined to answer.